back. This part we're talking about another 2D object called this polygon. So come to the tutorial. We have introduced two 2D primitive type. One is the circle, another is a square, and we will introduce another part. But before that is during last part we talk about the mass calculation. Actually, one thing is it's worth to introduce to you is remember if you go to the documentation page of OpenSCAD.org, I introduced this cheat sheet in the very early videos. This is our cheat sheet. You click that and you will get our long the version and the bigger version. And when it's based on the different group, like this is the basic the mathematical calculation, and also you have some the other ways you can use like a mathematical formula, not only sine, cosine. You can later we will see we will use a power square and exp. You can also generate randoms, minimum marks, and for this part we introduced a third, the 2D object called the polygon. But besides circle, square, polygon, you can also draw some text, and you use import projection. That are the 2D part. 3D is also, we introduce most of them, but you can see similar as a polygon, you have the polyhedron. So that is the 3D. This the poly, the shape, so that you can use. So let's go back to our tutorial. So for the polygon, is the purpose is trying to draw some complex 2D shape for this one. So actually, if we don't have this polygon, as you read this tutorial, definitely you can draw first our square, then you draw another square, but you rotate that to certain angle, and use that second square as a knife, and to use the difference, the function or method. You can remove this triangle part. But the tricky part or difficulty part is if you don't know the angle, you need to do kind of the calculation, and that will be the time consuming, because calculate proper angle will depends on, you need to have a very accurate the dimension, the measurement, and also you need to use those sine or cosine formula to transform that. That never be our 100% accuracy. So that's why is the reason we are introduced this polygon. Polygon is whenever you have definition for each point in the coordinates, you can draw this 2D the shape. So let's do the first one in the hands-on parts. So let me create a new model. Don't need to use this one, and we save as the part 2. So what's our model is profile 1 polygon. So let's use the approach 1. So it's this one. So we're starting to define the point. So we have 4 points. So let's see. So first point is this origin. So point we may need to use this the braces, and the point 1. So it's 0, 3, 0. So that's the 20 plus 10. So these are the 3, 0 in Y. And then we can measure here, that will be P2 is the 1530. Then here we directly go to this one, P3 is 15 plus 20 is 35 and 20. So here should be this, and the P4. We're back to Y, go to 0, but here is 35, 0. Then we have all the points. And then we will define these points into our list. So points equal to from P0 to P4. So, and we put that into our list like is some other language like Python. So you define this as a list. And the polygon, the usage is they just call those lists. So let's see, you have that immediately. So that is your polygon. So this is the P0, P1, P2. P2 is this 15 in X, 30 in Y. And this 35 in X, 25 in 20 in Y. So that is this polygon. You only need to define this n-1 points, and then the last edge they will close that when you call that polygon. So no matter it's back to the 0 or not, if you see here is I use 10, then that's also the last edge they will go to here. So go to the origin of first your point. So that is the polygon. So that means is if you have multiple points and you just want to do some irregular shape, use a polygon will easy to draw that. And also here is we also introduce one the useful tool. So if you don't draw that, I just wanted to know whether the point is okay or not, correct. So I can use echo. So that like is JavaScript, you have this message box or message, and you want to you print something. If you put this here, you can see here, read from console. So after this compiling design, they will give your echo result. So this echo result actually is what's the exact points, the real value. So they will load this P0 is to 00, P1 is 030. So you can examine this even before you make this drawing. So you can keep this echo here, and you can have the actual value, and then you also make this drawing. So that is the value you can have that. It's a very useful way that you can make some troubleshooting or debugging. And then this that also gave us our the second approach. So let me put this approach 2. So make this just the comments, and then approach 2. Actually, let me copy this. That gave us our easier way. So if I just do this directly, we don't need P0 to P1, P4. So let's see. So here, okay. So I forgot about the beginning one. So you can see you also get the same echo, and because I directly define the point with 4 points value, every point has our x and y in the coordinates. So that gave your exact same the result. So furthermore, is in the exercise is less common states use the approach 3. So I don't want this put in here because that's two the sentence. I just wanted to have one sentence. So for example, I can remove all of them. What's that coming to me? Same. So that is this approach. But if you compare this 3 approach, actually is this is recommended more because this even although it have multiple lines, but actually these give quite easy and read friendly. And if you want to change any points, you go to these numbers of points and do the change, and the others are kept as the variable. So that will make the things, the life easier a little bit. And if you put all these, it's kind of like our hard coding. Even it's one line, save a space of the program, but it's not easy to do the troubleshooting. So the suggestion is if you can use this way. So I will back to this uncommon, and this I will comment that. So then we have our appointed way. So let me save that. And you can also further is making the parameterized definition, because here we use this kind of absolute value. But if you see here, so I can see here from the this point to point 1 is x is no change, y is added 30 points, and then here from the second point to this one, y is no change, x is added 15. So that means is I can use something to make the additional this definition, make things also the better control. So you can control those parameters. So let's save on the second one. Profile 1 polygon with parameterize. So let's delete those. So we have this P1 to P4, but before that, let's add some parameter given dimension, and here is the points. So dimension is let's see the D1, D1, D2. This is another 1, 2. So H. So D1 equal to 50. D2 equal to 20. H1 equal to 20. H2 equal to 10. So let's see what's the, this is 20, this is 10, 15, 20. So we have these 4 special dimension. And then what we have that is this is the origin. And this 30, what's this 30 coming is on the height. So that is the H1 plus H2. So what's this 15 is the D1, and this 30 is here, H1 plus H2. And the 35 is D1 plus D2. This 20 is H1, 35, D1 plus D2. And then we have these points, and we echo points, and we have the polygon. So you can see here, the result is the same, but here when you want to change, let's see why I want to change this to 40, you don't need to change several parts into this points definition. You just need to change from this perimeter area. So if I want to see here, I want to go to the 40. So you get the different polygon through changing the perimeter. So that is the way is you can use as a kind of the improved approach. And then what we want to do our exercise is this one. We want to see this profile polygon. So let's don't see the code, and we try to define by ourselves. So that is the 3. Should say. Okay, how many the D? So this is the, let's remove this. So for D is 1, 2, 3. So I should have D1. D1 is 25. D2 is 12. And then I see whether I have the D3. Is this 15? Do I need to build this D4? D4, because it's not defined here, but it should be the D4. Should be D1 plus D2 minus D3. So let's define that anyway. So H1, we use this one, 23. And H2, 10, H3, 8. And then we have H4 equal to H1 plus H2 minus H3. So then we have this one. So whether or not these are same, I think this should be same height. This should be the same width or the dimension. So P1, P0 is 0, 0, and we go to here is H1 plus H2, and P3, P2 is D1, not D1, here is D3. H1 plus H2, just H1, excuse me, P3. That is 1, 2, 3, and P4, P3 now, 0, 1, 2. So that is the D1 plus D2, correct? And then go to the H1 plus H2. And this is P4, is the D1 plus D2, and that is the H3. And this one is P5. It's just D1 and 0. So looks like it's, we don't need this D4 and the H4 because they are not actually needed for calculation. Then we add just one more point. So you can see here is the easier thing. Then let's run that. It should generate this. Let's verify with the code. So we have this 6 perimeter. So correct, but that is the 23 on H. Yeah. So H first, D second. Then we have H1 plus H2, D3, H1, D1, D2, H1, H2, D1, D2, H3, D1, and then adding our P5 polygon. So that is the easier things. And then what we will do is a second one. This is the 2D. So whenever you have a 2D, you can make that into 3D with the 2 weapons you already learned. So let's make that extruding. Just one line you add to your polygon. So linear extruded. So height equal to, maybe we start from 20 and put that here. So you can see you make that into the 2D. So if you want to make that bigger, 550, so it's just more height. So that is the difference. And then we can make that another one is using the rotational transform. So let's save this to number 4, and you will get another transformation. So if I do this rotate, so then that's this angle. Because I still make that in the origin part, so if I put that 360, then extruding. So not rotate, RO. So you can see it's I got this shape, but not like this, because this one is we move that to in the X. So let's make translate in the X. Let's move that to 50. Then you get our ring. So, but if you don't move, it's just like this shape directly rotate. So that is the part is you can starting to consider how you can make the 2D with this irregular shape. So remember, is you can use Fn equal to 100. Then you get a smoother the shape here. So that is a part. Let's see what's the warning. Warning variable angle. So that's also the typo arrow. So no arrows now. Then you can make this render, save, and generate our STL file. So once you have that STL file, you can go to my GitHub. Let me push that to GitHub, and from here, so if I refresh from tutorial on chapter 9, this is the part. Let's see, is this the CAD part 3 rotational? So it's not coming. Let me see. So where is the file stored? It's here. Maybe it's stored here. So I think it's we did that export in chapter 8. So they save that in the default the folder or last folder. So STL. Let me push that folder. So let's refresh. So you got this model file. Then this model file in GitHub, you can view that through this directly in the 3D. Then they can also make this rotating, and you can examine from this wireframe, from the angle of the surface. So that is the way when you can export to this STL, that means you can send to your 3D printer. You can print this in the actual way. So similar like is what I have print something in my shots. It's like this. When you build that, it's easier for you to make that in the real world. Thank you for watching until here. Next challenge is we will create this racing car body altogether. Thank you.